This is problem set for the final and question number 1. Okay, so the question says that a person takes a trip driving with a constant speed of 99.5 kilometers per hour, except for a 21-minute rest stop. If the person's average speed is 61.3 kilometers per hour, how far does the person travel? Now this is a pretty standard question that they ask you for your physics finals. So it showed up a number of times, and so what I've tried to do is take some variables and put it together and then plug in the numbers later. Okay, so far we've been given an average speed, which is 61.3 kilometers per hour. And this has to be converted to meters per second. Similarly, the constant speed at which he's driving, the instantaneous velocity of that person when he's driving is, he's driving at 99.5 kilometers per hour. And this of course has to be converted to meters per second too. And then he stops for 21 minutes. Which then needs to be converted to seconds. Right, but that's just math. So what we have here is that the person's driving at 99.5 kilometers per hour, he stops for 21 minutes and keeps driving. Alright, and throughout this journey, his average velocity is found to be 61.3 kilometers per hour. And then we have to find out how far has that person actually traveled. Okay, so there are two segments of time here. One is delta t, right? And the other one is t stoppage. Delta t is the time that he spends behind the wheel driving at 99.5 kilometers per hour, and t stop is 21 minutes. Okay, so first, if you were to write the instantaneous velocity for the vehicle while he's driving, it's delta x divided by delta t, right? Delta x means the distance covered by the car when he's driving it. Delta t is the time period for which he's driving, right? But if you come over to the average velocity here, it's delta x, the total distance covered by the total time spent, which is the time spent behind the wheel and time spent at the rest stop. Alright? Okay. So now this is where the algebraic manipulations begin. Okay. So I start with delta t and I flip it up and I write delta t can be written as delta x divided by v instantaneous. And then I plug it in, this delta t, in this equation right here. When I do that, I get this equation at the bottom, if I can get this equation here, right? So we have everything we need, and so we need to separate delta x out of this whole messy term. So I take this huge term and multiply with the average, and this is what I get, right? And then I bring the delta x to the left side, separate delta x out, right? And then I get a nice little term for determining delta x given average velocity, t stoppage, v average, and instantaneous, right? Doing that, plugging the numbers in, and well, be careful, you have to convert this to meters per second and seconds. Plugging the numbers in, I get delta x is equal to 55.9 kilometers. Of course, you could do this without changing to meters per second. You could just directly take kilometers per hour, convert this to hours then, and do it. But my advice is always try and be consistent and work with the SI units. But anyway, so let's do a quick recap of what happened. We took the instantaneous velocity of the vehicle while he was driving it, and said that that's delta x by delta t. Then we wrote an expression for the average velocity, which is the total distance traveled divided by the total time spent. The total time spent was the time spent behind the wheel and the time spent at the rest stop put together. Then we plugged the delta t behind the wheel in there, in this expression, and then doing some manipulations, throwing terms around, we come to this big expression here, which gives us delta x. right? In terms of average velocity times stoppage and instantaneous velocity. Plugging the numbers in, we get what we require. Okay, so simple enough. A bit of math, a bit of understanding concepts, but definitely a favorite kinetics problem, a typical kinetics problem that you might see in your final exam. So that's that. Thank you.